Hi, this is Mrs. Jacobs, and I'm here to do a tutorial where I'm going through the first two problems of the coefficient of friction worksheet. So in our previous unbalanced forces problems, we've been using two different net force equations. F net from the free body diagram, right minus left or up minus down, and F net equals MA. So they've usually been two steps, maybe even a third step to solve for FG. That will continue. We will still be using those equations. There will just be a third layer. The third layer is the friction equation. It's FF equals mu times Fn, where FF is the force of friction in newtons, Fn is the normal force in newtons, and mu, which is that Greek letter M right here, kind of highlight that, is the coefficient of friction with no unit, and it's always a decimal. So sometimes we'll be using that friction equation right away. Sometimes if it says solve for the coefficient of friction, we'll be using it at the end of the problem. So kind of just like normal, we'll be using all the equations, but not necessarily in all the same order. It depends what we're given. So let me walk you through the first problem. A 2.25 kilogram soccer ball is rolling to the right across the ground and slowing down with an acceleration to the left of 0.75 meters per second per second. Solve for the force of friction and the coefficient of friction. I've already drawn the sketch and the free body diagram. There is no force to the right because it didn't say it's being kicked or pushed. It just says it's rolling. So it has velocity to the right and inertia to the right, but only friction to the left. The one thing I haven't done is I have not defined my variables, nor have I solved for FG. So let me do that first. So the acceleration is negative 0.75 meters per second because it said the acceleration was to the left. I know the mass is 2.25 kilograms. So to solve for FG, I'm going to do 2.25 kilograms times 9.8 newtons per kilogram. Plug that into my calculator. And I got 22.05 newtons. And even though this is a horizontal problem and Fn and Fg cancel out, I am going to need to solve for them because of that Fn in the friction equation. So now I know Fg and I also know Fn is 22.05 newtons. Next, I'm going to write my free body diagram equation. It is still a horizontal problem, so it's going to be right minus left. There is no force to the right, so it's going to be 0 minus FF. I can't solve for that yet because I wasn't given the force of friction. I can solve for the net force because I was given the mass, 2.25 kilograms, and the acceleration, negative 0.75 meters per second per second. So in my calculator, I do 2.25 times negative 0.75 is it's negative 1.6875. I'll just run that up to 1.69. F net equals negative 1.69 newtons. Over here, now we know, I'm going to go back to F net equals negative FF. So now I know the net force, which means I do know the force of friction. Negative 1.69 newtons equals negative FF. I can divide both sides by -1, and I get 1.69 newtons equals the force of friction. Now, in this case, I do want the force of friction to be positive because now I'm about to use my third equation. I don't want to plug a negative force of friction in here because then I'll get a negative coefficient. And there's only really positive coefficients. It's just a decimal that's positive. So I'm using my last equation. This is the new equation. Mu, this little Greek symbol, that's my unknown. What is known now is friction is 1.69 newtons. Mu is unknown, so I'll leave it as that Greek letter N. Normal force is known. It's down here. I solved for it way at the beginning. So that's 22.05 newtons. Now to get the coefficient, I divide both sides by 22.05. So I'm going to plug in 1.69 divided by 22.05 in my calculator. And I get that the coefficient is equal to 0.0766. I'll just run that to 0.77. Oh, I hate, they always like capitalize it once I press space in Google Docs. And that's my answer. That's the coefficient of friction between the grass and the soccer ball, or the ground and the soccer ball. It would be different if it were two different surfaces. And I know I did it right because I got a decimal. It's a pretty small decimal. Sometimes the decimals are bigger. They're going to be like 0.5 or 0.6 or 0.7. But in this case, it was very small, 0.077. Okay. I'm going to do the second problem. I'm just going to give myself a little bit more room by moving this. Moving this. Oops. I'll just kind of delete this. Okay. I'm just going to need more room at the bottom. Okay. We're still going to be using those same three equations. I just didn't have the chance to fit in that table because there wasn't enough space. Okay, we've got a 35 kilogram box. It's being pushed across the floor to the right by a student. Pulled across the floor to the right by a student with a force of 140 newtons. This time the coefficient is known. The coefficient of friction between the box and the floor is 0.28. Solve for the acceleration of the box. So I've got my sketch. I've got my free body diagram. Fn and Fg are equal. The applied force is to the right. You could call that, I'm not going to call it tension because it's not really a rope. And the friction is to the left. So the first thing I'm going to do is I'm going to solve for Fg. Let's do this over here. Fg equals the mass times 9.8. So 35 kilograms times 9.8 newtons per kilogram. And I got 343 newtons. So the normal force is also 343 newtons. Next, I go back up to the top. My second equation is F net equals right minus left. So it's going to be F net equals F applied minus friction. I do know the applied force is 140 newtons. That was given. But I don't know friction or F net right now. I'm also going to write out F net equals MA. But once again, I know the mass, but I don't know the acceleration. So in this case, because the coefficient of friction is given 0.28, I'm actually going to be starting with a friction equation. I'll just go ahead and paste it in here. Friction equals mu times Fn. I don't know Ff. I do know the coefficient. It's 0.28. And I do know the normal force. It's 343 newtons. The coefficient doesn't have a unit. So when I multiply 0.28 times 343, I get newtons. It's 96.04 newtons. Now I know the force of friction. That opens up the door to this equation right here because I know the applied force is 140, and now I know the force of friction. So, the theme is like solving one equation opens the door to solving for another equation. So I know the force is 140 to the right, and now I know it's 96.04 newtons of friction to the left. And my calculator, I'm going to do 140 minus 96.04. I got 43.96 for net force. It's positive, so it's to the right. And then the last equation is to solve with F net equals ma. In this case, I do know the net force, so I'm going to plug that in. Oops. It's 43.96 newtons. I do know the mass. It's 35 kilograms. I don't know the acceleration of the box. So I'm going to divide both sides by 35. 43.96 divided by 35. I got 1.256. I'll just go ahead and run that to 1.26 meters per second per second. It doesn't matter. You could keep 3 decimals. It's okay. So in this case, this box was speeding up because the applied force was greater than friction. The acceleration was positive. The net force was positive to the right. And the box was moving to the right. Okay, you're going to be trying to solve the next 3 problems and turn it in before the end of the period so that I can see what you have accomplished today. I'm sorry that I'm gone a second day in a row. This was a planned physics curriculum day where we're kind of writing the tests for the rest of the semester. So I need to be there, but I will be back tomorrow and we will work some more on these problems.